Trigonometry, the study of angles and sides of right triangles, play a crucial role in solving various real-world problems. Let's dive into how sine, cosine, and tangent function, often remembered by the acronym SOHCAHTOA, are applied in everyday life. Let's see some examples of daily life application for the trigonometry. Imagine a fisherman using radar to locate fish. Trigonometry helps calculate distances and angles, making his catch effortless. Similarly, engineers use trigonometry to position structures like lighthouse, ensuring safe navigation for ships. From fishing to navigation, trigonometry's practical applications are all around us, simplifying everyday tasks and making life just a bit easier.
For the problem statement, there are two. The first one is to determine the angle and position of a submarine underwater, and the second one is the distance between a fisherman's boat and a lighthouse.
So now, let's see the trigonometric explanation. Picture this, a boat smoothly sailing across the ocean, using a distant lighthouse to figure out how far away it is and which direction to go. But how does it all come together? Trigonometric step in, turning angles and height into helpful information for navigation. Using a sextant to measure the angle from the fisherman's viewpoint and armed with the lighthouse average height of 63 meters, sailors use trigonometric principle like SOHCAHTOA to calculate the distance. By matching up the height as the opposite and the distance as the adjacent, trigonometry unlocks the secret of the sea, helping sailors steer confidently and stay on track with precision. For the first step, we have to label the triangle sides. Identify the opposite, adjacent, and angle of the object in triangle diagram. For the step 2, we have to choose the trigonometric ratio. The ratio depends on which side we have taken and which side we are finding. In this case, we will use TOA, which is opposite over adjacent. The third step, we have to apply the formula. Substitute the side length and the angle into the correct formula triangle. The final step is to complete the calculation to find the distance of x, round to the required accuracy. And now, we know that the distance between boat and lighthouse is 109.12 meters.
To find the radar of the boat, there are 4 trigonometry steps. First, in the radar of the boat, any object in the ocean is located by a coordinate represented by xy. To find xy, we have to apply the coordinate. X is represented by the length or distance between boat and object, while the y is represented by the depth of an object. Third, applying the formula. Substitute the length and opposite side into the correct formula triangle. Use SOHCAHTOA. For the fourth step, complete the calculation to find answer. Round it to the required accuracy.
Firstly, we need to label the triangle sides so we know the value of adjacent is 500 meter and the opposite is 700 meter. Then, from there, we can choose what formula to use, and in this case, we can use TOA to find the angle.
For step 3, we can apply the formula by using tangent is equals to opposite over adjacent. By using this formula, we can find the degree between boat and the submarine in the ocean. For step 4, we have to calculate the degree between the boat and the submarine in the ocean. By using the formula before, which is tangent is equals to opposite over adjacent, we can find the inverse of tangent, opposite over adjacent, and we can find the degree. And after that, we have to round it to 2 decimal points.
As we know, we can also determine the value of hypotenuse by using Pythagoras theorem, which is a squared plus b squared equal to c squared. Hence, the final answer will be 901.39 meters.